Okay, we begin this section talking about the profit function. Be sure to read the examples on page 1 on how to determine the total cost function and the total revenue function. So for the profit function, one thing I do want to point out is what X represents here. For the profit function, as it says up here on the top, X represents the number of units that are produced and sold. In fact, it's the first X units that are produced and sold. It's not quite the same X that's used for the total cost function. There, X represents the total cost of producing the first X units. At any rate, let's continue here with the example. The total profit is defined to be total revenue minus total cost. In terms of the revenue and cost functions, P of X is equal to the revenue function R of X minus the total cost function C of X. So let's take a look at the example now. It says using the results from examples 1 and 2 from page 1, determine each of the following. A, the profit function P of X for the company TVs R Us. So we notice that P of X is defined to be R of X minus C of X. It's a good idea whenever you're going to subtract the cost function from the revenue function, be sure to enclose it in parentheses the way I have here for the following reason. To remove the parentheses, since I'm subtracting the cost function, I have to distribute -1. And what happens when you distribute this correctly, notice that the sign of that last term turns out to be negative. And by the way, in the first set of parentheses, this is the result from example 2a, and this is the result from example 1a, and you'll find those on the first page of the handout. So I enclose both of these expressions in parentheses. Then the next step is to distribute this negative, and notice how it changes the sign of that last term and it becomes negative. It's very important, or else it's going to throw off the expression for the profit function. Okay, continue now. I write P of X here is going to be this first term, negative x squared minus over 80. That's this term here. And then what I'll do, I'll combine my like terms. Notice that this term here and this term over here combined together. 400 take away 270 is 130x. So I get 130x, positive 130x. And then notice that this final one right here is a negative 210. Now this is very important. This profit function is valid on the following interval between 0 and 12,000. This, this interval here is going to play a big role when we go to do the break-even analysis. Now, where did this interval come from? Well, if you look at example 2 on page 1, there, when we're constructing the revenue function, we use what was called the price-demand equation. The price-demand equation was only valid between the interval from 0 to 12,000. Well, since the price demand equation depends on this interval, the revenue function that's sitting up here also depends on the interval from 0 to 12,000. The total cost function, its domain was all real numbers, or all positive real numbers. So the domain for the profit function has to match the domain of the revenue function. So the domain of the profit function is between 0 and 12,000. In other words, X here represents any number in a given month when the first, let's say X are equal to 10,000, then that would be um, the total profit from producing and selling the first 10,000 units in a given month. Anyway, now that we have the total profit function, part B says find and interpret P of 1,000, P of 2,000, P of 3,000. So I simply take 1,000, plug it into this profit function right here, and the computation, you should verify it, turns out to be, notice, negative 92,500. So in other words, we realize, this company realizes a loss doesn't make any money, it loses money. So, and then when we plug in 2000, P of 2000, I'm plugging in 2000 in, back into the profit function, I get 0. So we don't lose any money, we break even. We don't lose any money, and we don't make any money. And finally, at 3000, P of 3000, we get $67,500. So we get a profit there. So how would we interpret this? P of 3000? Well, this P of 3000 represents the total profit from producing and selling the first 3,000 TVs in any given month. And that turns out to be, and by the way, this is in dollars right here. So this is $67,500 profit from producing and selling the first 3,000 TVs in a given month. Okay, like on the second example here on part B when we did P of 2000, sorry, P of 2000 here, notice that the answer was 0. So we call any value that makes the profit function 0, we call that a break-even point. So as it says down here in the break-even analysis, x of 1 is called the break-even point of the profit function P of x if P of x of 1 equals 0. So the way you find the break-even points of a given profit function, if you want to find them analytically, you set the profit function equal to 0 and you solve for x. When we do what's called the break-even analysis, we want to know when do you make money and when do you lose money. So we want to find these values of x. Intervals of x for which the profit function is positive is called the profit region. When we sketch the graph of the profit function, you'll see that that corresponds to where the graph of the profit function is above the x-axis. The values of x for which the profit function is negative is called the loss region, and this corresponds to where the graph of the profit function is below the x-axis. Okay, so instead of graphing, you can do the same thing in terms of the cost and revenue functions, but it's a lot simpler and clearer to do everything in terms of the graph of the profit function when you're doing the break-even analysis. So be sure to listen to the next video where we actually do example number 4 on doing the break-even analysis.